So hello, everyone. Thanks so much. As more people are filtering in and joining us, I thought I'd just start out by introducing myself and our topic. So I'm Stephanie Weisenbach, the Nature Alberta representative on our Alberta Citizen Science Community of Practice Steering Committee. Thank you for joining us for our 8th gathering of our community practice, which features Indigenous voices in environmental monitoring. We will be hearing from Alvin First Rider, Blood Tribe Land Management, about Kainai Miistakis coexistence, and Elliot Fox, Kainai First Nation, about Blackfoot Confederacy Tribal Council Native Trout Recovery Project. In the spirit of truth and reconciliation, we acknowledge that the land we know as Alberta resides within Treaties 6, 7, and 8, as well as portions of Treaties 4 and 10. We recognize with gratitude that the lands and waters we hold so dear today have been stewarded by First Nations, Inuit, and Métis peoples for centuries. In this community of practice, we believe it is very important for citizen science to include Indigenous peoples and traditional ways of knowing, and to value not only data, but also our relationships to the natural world. This is why we are so happy to have Alvin and Elliot here with us to share their knowledge and give us examples of how we can all work together as we learn and make progress on reconciliation. I'm now going to tell you a little bit about us, a little bit about you, and then I will introduce today's main event, our wonderful speakers. The Alberta Citizen Science Community of Practice is open to all practitioners, researchers, environmental management managers, educators, project coordinators, and volunteers who share a passion for citizen science. CitSciAlberta.com is a space to share ideas, information, and resources to advance design, delivery, and evaluation of citizen science in Alberta. The Alberta Citizen Science Community of Practice activities are planned and coordinated by a steering committee. Current steering committee members involve representatives from Alberta Environment and Protected Areas, Inside Education, Nature Alberta, that's me, Alberta Lake Management Society, Pigeon Lake Watershed Association, Battle River Watershed Association, and Miistakis Institute. We're a great group of people to connect with, so I encourage you to get involved by joining the conversation. There's a few different ways you can do that. You can find us on Instagram or Facebook with the username CitSciAlberta. And if you look for this person documenting the fawn with the itchy bum, that is our profile picture on Instagram and Facebook. So that's how you know it's legit CitSci Alberta. I did actually just nab the CitSci Alberta username on Facebook on Monday to help make us more visible and easier to find. So that's one way you can support our growing community is right now, if you go onto Facebook and type in CitSci Alberta and give us a like. And then after you're done watching today's presentation, you can share our page and give us a raving review to help spread awareness of our network. We also have a Slack channel. It's citscialberta.slack.com. It's a place where you can engage in conversation with like-minded individuals to share ideas, challenges, and resources. So it's basically like a chat room for all the coolest CitSci people. And you can also send us an email at info@citscialberta.com. So now I'm just going to share some of the information that you filled out when you registered. So a little bit about you. Many people are here today, work with the government, or a nonprofit organization, and then there's others including academic institutions, industry, volunteer, and others. People are coming in today from all over Alberta and BC, and then other places as well. I'm interested to hear where you're coming from, if not Alberta or BC. If you can type in the chat to show us where you're coming from, that would be helpful information as well. And the primary area of focus, most people are here today, varies quite a bit. There's many people that are focused on biodiversity and water, lots in the other category, and a couple in air and climate. Again, if you're in the other category, we'd be interested to hear what that entails in the chat. Just a quick housekeeping item to keep it clean, like these beavers' coats here. I will give a quick introduction to each of our speakers prior to their presentations. If you have any questions during the presentations, please type them into the chat box. I think there's two boxes at the top right now. There's a chat box and a Q&A box. Please use the chat box. Our steering committee member, Tracy, will be monitoring the chat, and she'll read those questions out to our presenters at the very end, once both presenters have had a chance to give their presentations. So it might be helpful if you include the presenter's name that your question is directed to help us keep it all straight. And we'll do our best to get to all of your thoughtful questions. We have two presentations today for Indigenous voices in environmental monitoring, including Alvin First Rider with Blood Tribe Land Management, presenting Kainai Miistakis coexistence, and Elliot Fox of Kainai First Nation presenting about the Blackfoot Confederacy Tribal Council Native Trout Recovery Project. I'm going to stop sharing my screen so we can get Alvin's presentation up on the screen as I give a short introduction. Alvin First Rider is a member of the Blood Tribe of Southern Alberta and a descendant of the Blackfeet Nation in Montana, both of the Blackfoot Confederacy. Alvin works as an environmental technician with Blood Tribe Land Management. Alvin has been an advocate for the voiceless flora and fauna of Blackfoot territory. He is an advocate for traditional use land management practice such as bison, cultural burning, and beaver restoration from a Blackfoot perspective. Alvin enjoys hiking, photography, videography, learning Blackfoot knowledge such as traditional and medicinal use of plants. Alvin is presenting for us today on the Kainai Miistakis coexistence to discuss how Blood Tribe Land Management is exploring the historical and contemporary relationship the Blackfoot people have with Miistakis, the beaver. Welcome, Alvin.
Thank you. Okay, Mr. Onikok, Natoyinasaksen. My name is Alvin First Rider. My Blackfoot name is Holy Descent, and yeah, I'm just glad to be here. Taking a little break. We have been doing some beaver mimicry the last couple of weeks, and we were doing some this morning, and I just quickly come to present on it, I guess, a little bit. And so, yeah, our project is the Kainai Miistakis coexistence project. We are looking at ways to better coexist with beavers on the landscape. Next slide. So yeah, just a little bit about Blood Tribe Land Management. We are a department of the Blood Tribe Administration in Standoff, Alberta. We operate under the authority of and the sovereignty of Blood Tribe Chief and Council and the Government of Canada to administer and manage our land use and occupancy of the Blood Reserve and Blood Tribe timber limits. The Blood tribe is based in southern Alberta, just neighbors of Lethbridge, Cardston, and Pincher Creek, Fort Macleod. So just kind of give you a general area of where we are. We work in conjunction with Indigenous Services Canada to ensure compliance with applicable legislations governing the use and dispossession of flood reserve land. Next slide. So just a little land user kind of summary of what we kind of have on the landscape. There's originally 351,000 original acres of reserve boundary. Of that, there's 142,000 that is grass, roads, house lots, and considered unproductive areas. 200,000 of our 351,000 acres is cultivated, irrigated, foraged acre land, which fragments our grassland parcels into 38,000 acres. We're surrounded by three main rivers, the St. Mary's, the Belly, and the Old Man, and that kind of roughly gives us 4,795. The original reserve was a lot larger. We were entitled to roughly 1,838 square kilometers of reserve under Treaty 7. Of that, roughly 420 kilometers was stolen from flood reserve and is in court case right now. So we roughly have 1,342 square kilometers that we work with right now. The rest in land claims. We were considered the largest contiguous reserve by area, and we're hoping to continue to grow our land resources. We were placed in Blackfoot territory by Creator Napi, and if you want to go to the next slide. So yeah, just the kind of little history of our relationships with the landscape is we view our land as kin. The animals, the plants, the water, the mountains, they all have relationship value to us, and a lot of them have stories and songs that go with them. Waterton Lakes, long ago, we were gifted by the wetland creature Miistakis with kind of spiritual powers. They gifted us a sacred collection called the Beaver Bundle, which each spring we open and celebrate the rebirth of the new year. So with that gives us the wetland riches and stories and songs and values that kind of give us our Blackfoot way of life and how we function from year to year, and how we pay our homage to the relationships that we've had since time immemorial with our land, our fauna and flora. Next screen. So just there's a list here of Blackfoot words that kind of are important with the relationship with beaver in our beaver bundle, and just the Miistakis in general. And then there's a little map here that kind of gives you a general area of the Blackfoot territory, which is stretched from the Rocky Mountains out to Manitoba, North Dakota, in kind of the North Saskatchewan River, and then down to the Yellowstone. These are verified through different stories on the landscape, cultural significant sites that have been verified and reignited with once we get back on the landscape and are able to visit these places that have effigies and cultural sites that have been longing for that connection to our landscape. Each cultural site is connected to to the next, and then which is connected to our daily life today. And as we're able to rematriate those relationships on the landscape, we're able to reignite and strengthen that bond with our land. Next slide. So yeah, we a few years ago was approached by Miistakis and Cows and Fish, and they wanted to see what the interest was and what type of relationship that we had on the landscape with Miistakis beavers. So in collaboration with them, we created the Ghana coexistence project with beaver in the nation here. Through colonization and the contemporary views and infrastructure, Miistakis have been viewed as nuisance pretty much everywhere in Alberta. And these three pictures kind of show a varying degree of issues that our occupants and our homeowners have experienced. Two first pictures are in lower standoff and are of the same dam, but are creating a different problem. So the dam there is right next to a house. Like there's a house like 50 feet away, and the sump pump continuously runs, which burns out quite a bit, and the foundation eventually gets flooded once the water levels rise. So the occupants there have been very adamant about getting some kind of coexistence structure implemented. And then right next to it, the power line to the house, beavers are chewing through the trees, knocking back into the power line, which creates a hazard for the house, the children that live there, and then the contemporary infrastructure that needs to be replaced every time a tree falls into the power poles. And then the other one is of a beaver dam that is slowing down the water, causing the land users upstream not able to get the water they need to have livestock and grazing on the landscape. So we're looking at ways to implement pond levelers so we can ensure that continuous flow, but also ensure that the homeowners' houses are not flooding. We have a few places on the reserve that have these and are in need of these pond leveler infrastructures. I recently just helped assist put in a couple, and it is quite the process, and but is much needed on the landscape for a true coexistence strategy to happen on the landscape. We were going to do a pond leveler at the dam on the first picture. We went this spring to go and do some ground reconnaissance, and due to irrigation, the water level was pretty much shut off and non-existent. So we decided not to put one in there because the stream was dry. I went out there a week ago, and it's looking like the picture again, and it's creating problems. So yeah, I guess in the springtime when the irrigation shuts off our access to water, we'll have to get in there, put in the pond leveler, and then go from there. But yeah, irrigation has also caused some issues just around the beaver dams in itself. Next slide. So another aspect of our project is citizen science. We were looking at satellite imagery to identify potential beaver habitat on the landscape, whether it was historical, old beaver dams, old beaver lodges, or currently being used. We would go out, or we would identify through satellite imagery through like high probability beaver habitat. And once that was verified through citizen science, our technicians would go out on the landscape and verify whether there were beaver presence historically or they are presently there. Next slide. So yeah, just kind of the words from the researchers. Partnering with CitSci, we will make our watersheds more resilient to flood, drought, wildfire, and other risks associated with climate change. That's the big push here, is that resiliency to climate change. We've been in extreme drought conditions, and our water has been shrinking. Our rivers didn't even get a flood this year. The snowpack was pretty much non-existent, and we're needing these outside solutions to help rejuvenate our groundwater, and our surface water. So we're looking at ways to implement that. Just a little bit about the beavers from space. We had a number of people from all over Alberta contribute to verifying through satellite imagery. And through that, we were able to just get out on the land and verify where beavers are, where they're needed, and how we could start implementing these coexistence strategies. Next slide. So yeah, kind of to begin our beaver mimicry. So last year, we initiated the project installing 3 BDAs, beaver dam analogs. So initially, we gathered data. We surveyed the stream profile, did riparian health assessments, and looked at the best areas that we could flood, basically, and recharge the groundwater. Initially, we had like up to 10 BDAs we were going to install in this area, and we dropped it down to 3 just because of time. We heavily engineered these BDAs, and we were able to install 3 within a week last year, that we were able to get on the landscape for our land occupants that have horses that don't have water. So yeah, next slide. So yeah, initially it starts off with gathering the data. Then we go out and harvest willows from the area. Another thing, kind of, our willow population is dwindling, especially the ones that we utilize for sweats. They're just not big enough or thick enough. So this is also kind of a 2-pronged approach. We're able to recharge those medicinal plants or traditional plants that we utilize and get them a part of our BDAs. We try to also spread sweetgrass seeds and mint seeds that we along the beaver dams, just so that kind of helps our medicinal and traditional plant, our culturally significant plants. So yeah, that's just we usually gather around 3 to 4 truckloads of willows for the 3 BDAs. So next slide. Here we're gathering untreated longs. We have Elliot, Truman, Big Swallow, and we would kind of basically in 2 rows, based on the stream profile, we would install 2 rows to weave the willows into next slide. So right here we're weaving, hauling dirt. So we had a kind of a mixture of unique buffalo dung, wood chips, and soil that we would mix, and then we would utilize that as kind of like a base cement. We'd weave, throw the shovel full of our mixture, pound it in, and then continually to build up until it was pretty tight to hold back the water. We really didn't want them to blow out. We wanted them to stay in place. And so we tried to engineer them as much as we could and try to channel our inner beaver. So yeah, next slide. So yeah, here's kind of like the initial, what I was talking about, is installing the 2 rows of untreated posts. The channel was very compact, which made it very difficult to get these in, even just half a foot. So we battled through the dirt, and we got them in, and we were able to install our 3 BDAs. The second picture there is our third BDA, which was our highest. Took a lot of material just to build that one. We're pretty proud of that one. At the end of the week, there was 5 of us that were able to finish that, and that was kind of like one of our main BDAs that we needed to build up enough to hold the water back and slow it down. They basically act as speed bumps and slow the water down enough to recharge the groundwater and keep it there at least for a couple months. So next slide. Yeah, next slide. Yeah. So yeah, a lot of this work wouldn't be possible without collaboration with the outside environmental NGOs, our partners, and the youth. We had the high school come out last year and assist us for a few days, which roughly they bring out 20 to 30 kids on each day. And there was a huge knowledge transfer there. We were able to teach them about watershed health, riparian health, traditional plants, and the need for water storage, the need to implement these type of man-made beaver mimicry methods on the landscape, because without them, our water is just not reaching where it needs to be due to irrigation, drought, and other factors. So we're able to reach our youth, which is a huge drive, is that education and awareness push is ensuring that we get to our youth so they could go out and teach their elders, their parents, and we could get these type of strategies implemented on the landscape. And that kind of helps that coexistence with beavers and show the need that we need to be able to strategically live with beavers on the landscape instead of just looking at ways to get rid of them. Next slide. So yeah, here's just kind of more of the finished product. The students actually built that one BDA by themselves, which they're very proud of. They come out those 2 days and they're able to build that one up. And without them, we maybe only would have been able to get 2 in. So they're very instrumental in getting there, and we're very appreciative of the help that they were. That was kind of like a conservation class that come out, and we're trying to find other ways that we could get out on the landscape with them. Whenever we can get our youth out on the landscape with any of our projects is a plus. Like, we have so many projects on the go, and getting them out on the landscape with us to learn, and we're able to provide that knowledge transfer is huge. So there's just another picture of the finished product, the BDA. There's Jameson Russell, was one of our technicians last year, Truman, myself, my boss, Kanzi, and Carrie. We were able to complete the final structure there. And there's Truman just at the end of the day on a Friday afternoon, or Friday evening, actually, just kind of unwinding, putting the Thor hammer in the air. But yeah, next slide. Uh-oh. But anyways, yeah, so we were able to get the 3 in, and they did their job. So yeah, next slide. Yeah, so they did their job. They're able to hold back enough water to where it at least started to puddle. It's not going to happen all in like the first year. It's a long-term strategy project, and we're hoping to, as the years progress, we see the groundwater recharge. So in that area that we built the first 3, we installed 4 more. A little further downstream, where it's called the Prairie Blood Coulee. So there's a Y where one coulee meets the other. We built one right there to try to back up the water into the two coulees to help recharge both areas and slow the water down. Next slide. So yeah, here's just another example of the water being slowed down, kind of the PDA doing its job. It's holding back the water, slowing it down, and we were able to at least provide water for a month or two longer than it usually would have stood. Next slide. So yeah, like I said, without partners, these type of projects are pretty much a dream, right? So with the help we had last year, it was tremendous help. And this year, the help we've had, we've been installing two. So I've been doing it the last 2 weeks. Today, we're installing in a different area. There was actually water that wasn't there last week, which kind of created a challenge in itself this week. But we installed one yesterday and it did its job right away. It started to kind of back up the side channels and create that water storage that is much needed in those areas where water is non-existent due to irrigation and drought. So just, yeah, I'm very thankful for our partnerships and looking at the future and the possibility of installing more, getting more coexistent strategies on the landscape, whether it's fencing, tree wrapping, and pond levelers, beaver mimicry, or just finding ways to help provide that food cache in areas where people have planted trees and don't want their trees ate, but there are beavers in the area, so finding ways to coexist but not destroy their trees. So yeah, it's been a interesting learning experience, channeling our inner Miistakis. Thank you.
Thank you so much, Alvin. If everyone wants to give a round of applause in your reactions there. Thank you so much. That was wonderful. The collaboration on the beaver mimicry project there with the youth was absolutely amazing and great to hear all about. So thank you for sharing with us. And we'll have questions at the end after Elliot's presentation. I know there's a few questions coming in, so we'll have you answer those after Elliot's presentation. So, Makoyu Guinea, I hope I said that right, Elliot. That's Elliot's Blackfoot name that translates as wolf collar. So Elliot Fox is a member of the Kainai Blood Tribe First Nation Blackfoot Confederacy who resides on the Blood Reserve and has worked in the field of natural resource conservation and land management in Southwest Alberta for the past 29 years as a fish, wildlife, forestry, rangeland, and climate adaptation technician with Parks Canada, Waterton Lakes, Alberta Fish and Wildlife, the Blood Tribe, the Earthwatch Institute, and the Resilience Institute. As a land manager with the Kainai Blood Tribe and Piikani First Nations, and was also appointed to the National Aboriginal Land Managers Association of Canada Board from 2006 to 12. Elliot is currently working as an independent consultant. More recently, Elliot has been appointed as a member of the Parks Canada National Conservation and Restoration Indigenous Advisory Committee, the Crown Managers Partnership Landscape Conservation Design Committee, and is a board member with the Canadian Parks and Wilderness Society Southern Alberta chapter. He is currently working on the 4th year as a consultant assistant project manager for the Blackfoot Confederacy Tribal Council Native Trout Recovery Project as an Indigenous conservation consultant with the Miistakis Institute and as a Crown of the Continent Indigenous Landscape Protection Coordinator with the Yellowstone to Yukon Conservation Initiative. Elliot is a graduate of the Renewable Resource Management Environmental Science program at Lethbridge College, 1994. Elliot is presenting for us today on the 2002-2023 Blackfoot Confederacy Tribal Council Native Trout Recovery Project, Blackfoot Shared Leadership, and Capacity Support in Native Trout Recovery, addressing climate change, non-native species, and habitat loss. Welcome, Elliot.
Okay, Stephanie, can you guys hear me and see me?
Yes. Yes.
Okay, I can't see myself, but that's okay. Yeah, so thank you, Stephanie. Okay, gusto na ko makoyo kini. Kainai sa matsimpo yeah, I just said hello in my Blackfoot language. Glad to see everyone today. My name is Wolf Collar, or Makoyo Kini, as Stephanie said. So yeah, thanks for inviting me. Glad to be here, and I guess I'll just get going here. So yeah, I'm going to be presenting on the past 3 years of research. So 20 to 23 Blackfoot Confederacy Aboriginal Fund for Species at Risk Native Trout Recovery Project. So it's a Blackfoot shared leadership and capacity support in native trout recovery, addressing climate change, non-native species, and habitat loss for today's meeting. Next slide, please. Yeah, so this is traditional Blackfoot territory. If you want to click one, just click the arrow. Yeah, there we go. Yeah, so our territory included lands in what are now Alberta, Saskatchewan, Montana, and Wyoming, and was bounded on the west by the Rocky Mountains, on the north by the North Saskatchewan River, on the east by the Great Sand and Cypress Hills, and on the south by the Yellowstone River. Although they're finding more Blackfoot sites beyond those boundaries. Anyway, that's kind of our territory, almost right in the middle of the continent. Our study area, which was in the Oldman and the Bow River drainages or watersheds, is also in the crown of the continent ecosystem. And that's the yellow area you see highlighted on the map. This area has been called the water tower of North America, as there's millions of people that depend on the water that drain from the mountains. Next slide. Yeah, it's hard to see. Yeah, but it's the green boundary is the crown of the continent. So that's the ecosystem area. So it goes like you can see southeast BC, northwest Montana, southwest Alberta. So it includes some of our blood reserve land, the Begunny Reserve, and other areas. Oh, and the Blackfeet Reservation across the border in Montana. Next slide. Yeah, our study area is also within the Yellowstone to Yukon, or Y-to-Y ecoregion. So it's part of a large landscape. Y-to-Y is trying to conserve. They're trying to conserve the natural areas in this area from Yellowstone to Yukon. Next slide. Yeah, so as you can see, there's the North Saskatchewan River, the Yellowstone River. The two gray shaded areas on the north, right east of the mountains, are the top one is the Bow, and the bottom one is the Old Man watershed. And then the pink shading you see are the current reserve lands. So Siksika is on the Bow. Got Begunny and Kainai, or the Blood Reserve, in the Old Man. And on the bottom there in Montana is the Blackfeet Reservation. The St. Mary River and the Belly River and the Waterton River all originate in Glacier National Park, and they're also included in the Old Man River watershed. Next slide. Yeah, so as you can see, just kind of a blown up map of what I just explained. So you can see that a little bit better. That's our study area. Next slide. So the Blackfoot Confederacy consists of the 4 Blackfoot nations, Siksika, Piikani, Kainai, and Amskapi Piikani. And as I said, the reserve lands overlap the Bow and Old Man rivers. The only watersheds east of the Continental Divide where both bull trout and West Slope cutthroat trout are native. And our project was funded by the Department of Fisheries and Oceans, Canada. Next slide. Yeah, just keep clicking. Yeah, so this is just a description of the Blackfoot Confederacy. I'm not going to read all of it just because we're tight for time. They basically collaborate with the 4 Blackfoot nations and meet with the chiefs and other managers on common issues. Yeah, just to restore, protect, honor, and enhance the collective culture, language, and self-identity of the Blackfoot people, and to establish political and economic sovereignty over Blackfoot territory, including natural resources for the benefit of current and future generations of the Blackfoot people. I guess I did read it. Yeah, this is too wordy. This is basically where we get our funding. It's called the AFSAR, or the Aboriginal Fund for Species at Risk program with Department of Fisheries and Oceans, or DFO. So that facilitates active participation by Indigenous communities in the implementation of the Species at Risk Act. And it invests in organizational capacity, encourages activities that conserve and/or recover species at risk, and supports community-led documentation and management of Indigenous knowledge. Next slide. So our objectives. So we worked with all the 4 nations of the Blackfoot Confederacy. So we brought in technicians employed by each nation. And the objective there was to build capacity. So we trained the technicians to conduct eDNA, or environmental DNA sampling, in various tributaries of our study area, being the Old Man and Bow River watersheds. And eDNA determines the presence or absence of those native trout we're focused on, being cutthroat, or West Slope cutthroat, and bull trout. We installed water temperature data loggers in various tributaries of the Old Man and Bow. We conducted stream habitat assessments and worked with various government and environmental non-government agencies to restore stream habitat that's been negatively affected by human development. We conducted West Slope cutthroat and bull trout red surveys in various tributaries of the Old Man and Bow to confirm cutthroat and bull trout spawning activity. And the final component was we interviewed Blackfoot elders from each of the 4 nations just to find out about the significance of native trout, water, and Blackfoot place names in our traditional territory. Next slide. If you click it again. Yeah, so our purpose, like I said, was to build Blackfoot capacity and expertise as guardians of East Slope watershed integrity through training and mentorship in assessing, managing, and restoring in-stream and riparian native trout habitat. We also gathered Blackfoot values and holistic ways of knowing about the study area, water, and native trout, and bringing this together with scientifically derived watershed values in a respectful manner that increases Blackfoot engagement in native trout conservation and restoration activities. So this slide is just some of our technicians and managers conducting a bull trout red survey on, I believe this is the Old Man River. So you can see on the left there's Alvin, in the bottom center is Kimmy Houle, the project manager with the Blackfoot Confederacy. The top left is Blair, little mustache. He's a technician with the Piikani Lands Department. And on the right is Joseph Manyfingers. He's from the Kainai First Nation, but he's employed with Parks Canada and Waterton. So Joe and Carly Greer Stewart, who's from Piikani, are Parks Canada employees that joined us on some of our field days. So this is just one of the spawning bed surveys. Next slide. So our focal species were West Slope cutthroat trout and bull trout. So those 2 species are listed as threatened in Canada and Alberta. The cutthroat trout are listed as a species of concern in Montana, and bull trout are listed as threatened in the US under the Endangered Species Act. Next slide. So the challenges facing native trout, those two species. Habitat loss resulting from human activities, including mining, logging, grazing in unfenced headwater streams, random camping, and off-highway vehicle use. Another challenge is the interaction of land use with climatic extremes, so floods and droughts, and you could probably include fire, and competition and hybridization with introduced non-native trout species being rainbow, brook trout, and brown trout that were introduced. Next slide. So this is the range of bull trout, the historic range in Western North America. On the left and on the right is mountain whitefish, their range. So mountain whitefish are the primary prey species of bull trout. So as you can see, they exist in really similar areas. The bull trout depend on the whitefish to survive. Next slide. And this is just the 14 cutthroat species in their native range on the left in Western North America. And on the right is West Slope cutthroat trout native range. So that's, yeah, that's where they traditionally existed. Next slide. eDNA sampling. From 2020 to 22, we took a total of 73 eDNA water samples from various tributaries in our study area. The samples confirmed whether or not the 4 different species of trout were present or absent. And those would be bull, West Slope cutthroat, brook, and rainbow trout. 2 of the trout are native and 2 are non-native. Next slide. A total of 12 of our technicians from the 3 Canadian Blackfoot nations were trained in eDNA water sampling and filtering. And I'll just add, since last year, when the border opened up due to COVID, we were finally able to collaborate with our Blackfeet Nation technicians. So we've been working with them for going on year 2. So that was really good. They're a real great help. Environmental DNA. So eDNA is an invisible trail of DNA that organisms leave behind. Organisms leave a trail of tissue behind them when they shed scales, skin, or hair, or other dead cells. DNA is made up of 4 nucleotides. Those are contained in our cells. Each species has its own unique DNA sequence that are unique species genetic identifiers. By collecting water samples and filtering the water, DNA from all the plants and animals in the water is captured on the filter. All the DNA from the filter is isolated and tested to see if any of it matches the genetic codes for the trout we're looking for. Next slide. So the lab we partnered with is from the University of Victoria, Dr. Karen Helbing's lab. So she analyzed and processed all of our eDNA samples. So they developed unique genetic identifiers for bull, brook trout, West Slope cutthroat, and rainbow trout. Yeah, so she's one of the leading labs in North America for doing this kind of work. Next slide, please. This is just some pictures of our technicians taking eDNA water samples. So yeah, we collect them from whatever river. We're trying to find out which trout exist in there. We filter the water samples, and as you can see on the lower right, Alvin is taking the filter that's been, the water's been filtered through there. He pops that in a little brown envelope, and we send that to the lab. Next slide. Next slide. I'm tight for time, so I'll just keep going. And I think the presentations here are going to be made available, I believe. Anyways, this was an overview of 60 of the eDNA sites we sampled so far up to middle of last year. So as you can see, there's quite a few. I don't have time to go through them all. Just kind of gives you a snapshot of where we were and what we found. Next slide, please. Again, our results so far. Next slide, please. So we discovered actually two new West-Slope cutthroat populations. One is in the upper Oldman River through the Oldman Gap. We actually stopped by the road, a gravel road, to look at this culvert on the lower right-hand side of the screen. And we were looking at how a culvert shouldn't be installed. Just showing some of the technicians. And then we walked across the road, and on the other side of the road was this pool. We saw these little fish swimming in there. So we took eDNA samples, and we confirmed that that's a new West-Slope cutthroat trout population. The other population we discovered that the governments weren't aware of was on Callum Creek, which parallels Highway 22 and goes south and drains into the Oldman River. Next slide, please. So the previous slide was Shale Creek. It's right below Cabin Ridge coal exploration site. So, obviously, in my opinion, if coal mining continues, those cutthroat trout will disappear. Next slide. Just pictures of us doing the eDNA sampling and filtering. Next slide. Habitat restoration. We did habitat restoration on 6 streams. I'm running out of time. So it did.
I think Elliot just froze. Okay, we'll just give him a minute to see if he can come back. While we're waiting, if people want to type their questions into the chat box, that would be really helpful. And maybe while we wait, because I know last time he froze and he took a while to actually be able to come back. Alvin, we have a number of questions. Maybe someone can just prompt me if they see Elliot come back. But Alvin, if you're available at the moment, we have a number of questions for you. And so maybe we'll start there, if that's all right. Thank you so much for your great presentation. This has been a really well attended session, and it's really exciting for the community of practice. Clearly, this really resonated. The topics really resonated with our community of practice today. Lots of interest in the beaver project, Alvin, and so I've got a list of questions here for you. The first one was, can you talk about if beavers can be translocated to your area? And also, what is the purpose of the BDAs? Is it to actually attract beavers?
So yeah, they can be translocated. It's difficult though, right? Like you have to do an assessment and ensure that you're not creating a problem where there isn't one already. Like you got to ensure that the people that are living around the area actually want the beavers, and you're not just going to have them trapped and then killed. That's also another issue is there's certain times of the year where they have to be moved, like roughly give them enough time to where they could habituate the area. So like now wouldn't be a good time for them because they got to be able to store food, build up their home. So it's quite the process to translocate, in my opinion. And then eventually, yes, right? Like you want the beavers to move in and take over so they can create those storage ponds that they do. Wherever there are beavers on the landscape, water remains even in the drought. So they create those pools, and they're much needed on the landscape. And Eventually, yes, we would want them in those areas. And we would need to probably do some tree wrapping just because a lot of the houses have trees that are old and they don't want them. They don't want to sacrifice them for beavers. So yeah, if they do occupy the area, we'd have to do some other coexistence strategies.
Nice, thank you. How far away from the seasonal creek or river are these BDAs installed?
How far they're away from, well, they're right in the stream, right? They're right in the seasonal ephemeral or whatever classification you want to use. So they're right in a pond or a stream that usually would hold water throughout the year. Due to the drought, irrigation, like they're just not getting the water it's needed at that time. So the purpose of these BDAs are to slow the water down and flood areas and fill the floodplains enough to where they hold the water for a month or two longer than they've been in the last few years.
Okay, thank you.
Yeah, they're either a part of it or they're right next to it. Yeah, I'm not sure that. I didn't quite understand the question about a seasonal stream. Yeah. They're pretty much, yeah.
If I didn't ask that question right, maybe you can just clarify in the chat if you have a follow-up. Do we have Elliot back, or can I continue? I'm assuming
I don't see
someone
him
will...
yet, so
Okay,
thank
not back.
Yeah,
Okay.
can you hear me?
Oh, yes, we can, Elliot. There you are.
Yeah, my Wi-Fi gets pretty unstable sometimes, and Murphy's Law just happened now. Anyway, yeah, sorry to interrupt.
No worries. Are you, Elliot? You kind of got cut off right at the end of your presentation. I don't know if you just wanted to kind of say anything as a final statement before we go into questions.
Yeah, too bad I didn't finish. I know we're going to be out of time here in like 3 minutes. Anyways, I was talking.
We do have until 1:30, so please go ahead and finish your presentation.
Okay. So Alvin kind of explained what they were doing with BDAs, and our stream habitat restoration is very similar. We harvest willow stakes, and we did habitat restoration on 6 streams. We were trained by an expert in the field, Dave Polster. It involved a variety of bioengineering techniques using live willow stakes. We did 4 streams in the Old Man River, Dutch Creek and Beaver Creek. Those are upstream of the Beat Gunny Nation. 1 on the Beat Gunny Reserve, Crow Lodge Creek, and 1 on the Blood Reserve, the Belly River. Yeah, so that's them. Next slide. So this is just pictures of us helping the Old Man Watershed Council and other volunteers pounding and, planting willow stakes. So this is at Dutch Creek through the Old Man Gap. And it was COVID, so you can see in the top right picture, we're all spaced. Next slide. Yeah, so we just pound crowbars with a sledgehammer. We pound a pilot hole, pop them out, and put the willow stakes in, kind of pack them so they don't fall over, and irrigate them if we've got water. So that's just some of our crew, including our ladies that are pounding those crowbars with a sledgehammer. Next slide. Spawning beds, or they're called RED surveys. We conducted RED surveys by counting reds, or the nests the trout build. So 4 streams were surveyed for West Slope cutthroat trout spawning activity. 3 of those streams we confirmed spawning beds. That was in Beaver and Honeymoon Creeks. And in the Carbondale River, we surveyed 13 streams for bull trout spawning activity. And all of those streams had bull trout spawning beds. We did quite a few in the Upper Old Man, so Hidden Creek, Dutch Creek, Racehorse, Daisy, Livingston River, and then just south of Banff, Smith Dorian Creek, we found bull trout, the North Belly River, the Highwood River, and the Old Man. Yeah, so that's where we found bull trout. So this is actually Star Creek. We were looking for cutthroat spawning beds. We didn't find any, but we saw cutthroat. This is up in the Crow's Nest Pass. You can see on the right, there's Crow's Nest Mountain. There's Alvin and Colby, two of our Kainai technicians. And in the bottom left, we didn't find spawning beds, but we saw cutthroat trout. So the bottom left is a little cutthroat trout. Next slide, please. So this is a bull trout red survey. Again, on the bottom left, you can see highlighted in red the clean gravel that's really easy to see in the fall. And so we would measure the length, width, depth, and GPS those. Yeah, so that's a spawning survey. On the bottom right, when we moved between streams or creeks, we'd have to decontaminate our wading, like our gear, so our chest waders and our boots, because whirling disease is now in the bull and the old man. So we just did this to prevent spreading whirling disease, which can stick to your boots and on your waders. Next slide, please. This is a cutthroat trout survey. So as you can see in the top, well, sort of the middle right, there's Beaver Creek watershed. Just above that, there's a red dot and a green dot, which just shows the start and end of our survey. So we confirmed West Slope cutthroat trout spawning beds there. And these are really pure West Slope cutthroat trout. It's public land that's that creek drains through before it drains through the Peak Onion Reserve. So there's a lot of human use, including logging, grazing, random camping, off-highway vehicles. So it's pretty, the habitat is really degraded in a lot of places, but they're hanging in there, and they're one of the last purest West Slope cutthroat trout populations in Alberta. So hopefully the government can help mitigate some of the damage in those areas. Next slide, please. Here's bull trout spawning beds. As you can see, it's in the Upper Old Man. Next slide, please. This is a bull trout spawning bed survey on the North Belly River. So on the map, kind of to the right of the slide, you'll see the pink area of land. That's the blood timber limit or timber reserve. So it's part of our reserve land that's surrounded by Waterton Park on 3 sides and Alberta on the north. And so the North Belly River flows, it originates in Glacier National Park, flows into Waterton, flows through our timber limit, joins the main Belly River and flows down to our main reserve, into the Old Man River, and eventually into Hudson Bay. So as you can see, it was really cold that day. Our flight got delayed. We got dropped by a helicopter right close to the US border. And we got delayed because it was snowing. So as you can see, Alvin's bundled up, and the Waterton Park fish biologist Paul is bundled up. And this is a really important population because it's transboundary. So that it spawns in Glacier National Park and they spawn in Glacier National Park and Waterton. But the migratory bull trout swim down after they spawn into the main Belly River because there's more food and it's more productive than the headwater streams where they spawn. So they're very similar to salmon. Actually, they're a salmonid. So they'll swim, they'll migrate back up to where they were born. It's called their natal stream. And spawn there, but unlike salmon, they don't die. And they'll migrate back into the bigger rivers. So it's a really significant population because it exists in 2 countries, I guess. So it's important because they're transboundary. Next slide, please. Yeah, so bull trout are also prey for eagles, mink, and other predators. So I wasn't here on this day that this picture was taken. Our crew was doing a bull trout spawning bed survey. I can't remember where this is, if it's in Hidden Creek, maybe in the Upper Old Man. But they were hiking up the creek and this bald eagle flew right above their heads. So they kept walking and they found this bull trout. So the bald eagle obviously took it out of the creek, which is shallow and really clear at this time of year, so they're really vulnerable. And this bull trout was almost 80 centimeters long. And it probably weighed, I'll bet you, 7 or 8 pounds. That's probably, can't do the math on metric right now, but anyway, yeah, it's a few hundred grams. So they're really vulnerable to predation too. Next slide, please. This is a spawning bed survey on for bull trout on Spinecop Creek, which is at the north end of Waterton Park. And this is our crew on that survey. We found bull trout spawning there, and they weren't found there before. They were known to be there, but no spawning beds were confirmed. So we confirmed those. Next slide, please. We installed water temperature data loggers in a whole bunch of new streams. So those were installed at 18 new sites, including 1 on the Blood Reserve and 2 on the Begunny Reserve. So once you install them, you pound them into the substrate or the river bottom with a piece of rebar. There's an electronic device you activate and you cap the lid. And we'll go back in next year. We've got an app on our phone. So we find the data logger, we'll activate it, and it downloads all the stream temperatures for the previous year every hour. So we're able to monitor the stream temperatures of those 18 new sites in different rivers. And the data helps us identify where temperatures are cold enough for native trout and helps assess the risk of the spread of whirling disease. Next slide. Here's where we installed all the data loggers. Yeah, so you can kind of see where they are. This is just a graph from one of the data loggers. This is on the Belly River. So it's an interesting graph. The blue line is way up top, just near the Waterton Glacier, the US-Canada boundary. And as you can see, it's pretty cold all year. It's less than 10 degrees. And it doesn't freeze in the winter because there's groundwater that keeps it from freezing. And that's why those bull trout spawn there. If they spawn where it freezes, the eggs wouldn't survive over the winter. So they look for this groundwater that comes out into the bottom of the river. And that's how their eggs are able to survive. And then you can see on the other graphs, further downstream, we installed 2 other temperature loggers. And as you can see, in January, between December and around mid-March, they froze. And then they got really warm in the summer. If we go to the next slide, I can talk a bit more about that. Okay, so as you can see, the bottom dark blue line for the graph is the North Belly River, and it doesn't freeze. The lighter blue graph line above that is further downstream, right by the Waterton Highway on the main Belly River. And as you can see, that froze. That's just below the Bird's Eye Ranch turnoff for those locals that know where this is. And then on the top yellow is a data logger we installed. It's the Blood Reserve boundary just north of Standoff. And as you can see, the water temperature there in 2021 and 22 got up to right around 25 degrees Celsius. So that's too warm for trout. Bull trout can only tolerate water temperatures of 20.9 degrees for 7 days, and any longer and they die. So it's getting really warm, and I think one of the contributing factors to the warming water is not only our global warming, but southern Alberta is the irrigation capital of Canada. So all of those rivers, at least in the Oldman, so the Oldman, the Castle, the Crow's Nest are dammed, the Waterton's dammed, and the St. Mary's is dammed. The only river that doesn't have a major dam is the Belly, but there's a major weir. So they're taking lots of water and sending it down east. So in my opinion, I think they're taking way too much water, and it's contributing to the warming of the rivers and the depleting water volume in those rivers. Here's us, a few pictures installing the data loggers. We had to point, and they're the white dot in the water. So you have to document that for the government of Alberta, where they are. We fill out a data sheet with the locations. So it's all recorded with the province. Next slide, please. We also assisted with fish rescues in irrigation diversion canals. So when the government shuts the irrigation water off, we go there. There's one fellow from the Begunny Reserve that's been doing this for, this year is going to be 33 years, I believe, rescuing those trout that would otherwise die if they're trapped in the canals. And then we helped Trout Unlimited Canada do the same on 3 other canals to save some of those fish. This is just a slide showing the Oldman Dam that dams the Oldman, the Crow's Nest, and the Castle. And the lower left arrow is Pincher Creek. So that's the only creek or tributary. So if any bull trout get over the dam and they get over there, they can't get back up to spawn in their in those areas where they were born. So the only other tributary they can migrate back up to is Pincher Creek, because that's below the dam. So we're working with the government to try to mitigate. We're hoping we can assist them in rescuing some of those bull trout below the dam and releasing them above and put them into the reservoir so they can swim back to their natal streams to spawn. They're talking about building a fish passageway. Anyway, it hasn't happened, so hopefully the government will mitigate that. Next slide, please. Just some pictures of some of the big trout. On the left is a brown trout from the Oldman River. It's the Pagan Friends along the river. This was a couple years ago. We didn't find any bull or cutthroat trout, but here's a brown trout on the left and a good-sized rainbow trout that we rescued. And we just put those back into the Oldman River. This is a picture of the big, the amount of volunteers that show up to help, and we release them back into the main river. So we caught some really big trout, but we caught a lot of small minnows and small trout. I think we caught over 1,500 fish at this site on the one day. Next slide, please. So there's the 3 green fish symbols you see is where we did the fish rescues on those canals. So between 2017, before our project, and 2020, a total of 8 large migratory bull trout with an average fork length of 552 millimeters were rescued from the Lethbridge Northern Irrigation District Canal. Without those bull trout being rescued, they would have died and been lost to the population. So hopefully they can mitigate some of the native trout that are being trapped in those irrigation canals. Next slide, please. I just threw this in because, and I mentioned last year we were finally able to collaborate with the Blackfeet Nation after COVID. So this is our former biologist, Matt Coombs, 3 of the Blackfeet Nation from Montana, those technicians. So we went down and assisted them. We took some eDNA samples out of Roberts Creek, which is this creek that drains off of Chief Mountain. And Jeremiah and the crew, we helped them electrofish. So they electrocuted some of the fish. So it stuns them briefly. It's a backpack with a battery. Stuns them briefly. They float up and you can net them and you can process them, weigh, measure, and identify them. So there are really pure West Slope cutthroat trout in this and another tributary that drain off Chief Mountain in Montana, drain north into Alberta, and then back into the St. Mary River, and eventually in the main Old Man River. So this is another really rare, pure West Slope cutthroat trout population we're trying to help continue to exist. We also conducted Blackfoot elders interviews. Next slide. I'm going to go really fast. Those 6 we interviewed. Next slide, please. So this is Mike Brewstead. He's from Kainai First Nation. Next slide. This is Shirley Crowshoe from Beagunny. Next slide. This is John Murray. He's an elder from the Blackfeet Nation. He was interviewed. This is David Striped Wolf. He's passed on now. So I interviewed him and he gave us some really good information. This is Clarence Wolf Leg. He's from Siksika. Next slide. And this is Wilfred Yellowwing. So they're all elders with our Blackfoot Nations. So they told me a lot about how, and so I asked them 3 questions. How are fish significant to the Blackfoot people? How is water significant? And what are some of the traditional Blackfoot place names in our territory? Next slide. So all of the elders said they heard that some of our old people traditionally didn't eat fish, but all of them also said they heard some of our people ate fish. Some ate fish a lot, others didn't eat much fish or any at all. 4 of them said some of their family members were avid fishermen, and all of the elders, or 4 of them said the Blackfoot people ate fish in times of starvation, and they all knew about a fish eater clan from the Kainai First Nation. Actually, my dad is from that clan. So I'm part of the fish eater clan. Next slide, please. How is water significant? All the elders said it was very sacred, powerful, and a gift to the Blackfoot people. They said it could also, if you weren't careful, it could also kill you, like in floods. And so 3 of the elders said our people received the beaver bundle from the water beings, or the Suika peaks, and that is the most powerful medicine bundle with over 100 plants, animals, and songs. 2 of the elders said that water and fire are what we need to survive. Without them, we would not be here. 4 of them said our people always knew where the water was when they traveled, so they could camp close to the water. Next slide. I'll skip this. Alvin covered this, so yeah. So that's basically the end of my presentation. And I've got some acknowledgements. Next slide. Yeah, Alvin talked about this, so I don't need to talk about it. Alvin did a really good job. Yeah, so that's about it for my presentation. So thanks for bearing with me with our technological challenges. Yeah, so I guess if we got time for questions, I can take some questions. Thank you.
Thank you so much, Elliot. That was fantastic. I think you missed the part where I was just appreciating the interest level from the community, and we are definitely going to run out of time because there's so many great technical questions. But before, so I will get into those and go as long as we can. But I'm wondering if we could ask you both just any, this is a really big question. So any tips or learnings regarding working on projects that braid Indigenous knowledge and Western scientific knowledge? And if we could maybe start with Alvin and then move to Elliot.
So yeah, reach out to your local nations first, whoever's traditional territory you're sitting on. Go to their technicians and start there. Work with them to identify elders to interview, and then just acknowledge it as the same. It's equivalent to, like, an elder is equivalent to a PhD, and you're getting a world-renowned education, and that needs to be considered. Like, when you're, a lot of people think that our elders' knowledge should come free, and it needs to be compensated as much as a professional. So yeah, they're donating their time and their energy. And sometimes it leaves them wiped out when we're asking so much. So yeah, just start small and build that relationship, and then get the First Nations involved so they could get the information you need.
Thank you, Alvin. Elliot?
Yeah, I would reiterate what Alvin said. So what we did, and Alvin is a member of one of our sacred Blackfoot societies. We call them Ganatumitak or Ganatumitaks, the Brave Dog Society. So Alvin's a member of that, so he knows a lot about our Blackfoot protocol. So with the encouragement of Alvin, in the second year, whenever we'd go to one of our sites to take water samples, to do spawning bed surveys, to help restore habitats, we would offer tobacco to the land just to give thanks for us being there to help these fish survive and to help us have a good day. And so we got everybody in the crew, we would have tobacco, and we'd give them some tobacco. And we would say a prayer, and they would offer their tobacco, yeah, just to give thanks. So that's, try to incorporate that. The Blackfoot Confederacy also was funded for 6 storyboards. So they're going to be located in 6 sites within the Bow and the Old Man. So there's going to be 2 storyboards at each site. One is going to talk about the significance of our native trout project and what data we found at that site. The other storyboard will talk about the significance of that site to the Blackfoot people. So there's going to be one in Waterton, one in the Castle River, one in the Upper Old Man, one in Kananaskis, one in the city of Calgary along the Bow, and one below the big bridge in the city of Lethbridge, just to tell people how those places are significant to our people. But yeah, I would agree with Alvin. You know, don't be shy. I know in my experience working with non-Indigenous people over the years, a lot are reluctant to engage with Indigenous people. I think some of them are afraid that we're going to get insulted, but you know, I would say just ask. And if you're getting any information from an elder, or you want an elder interview, our protocol is to always offer them tobacco and whatever else you can offer. There's no expected gift of what you offer them, but at least tobacco. They'll accept money, blankets, or whatever you got to offer. So that's what I would say. Yeah, thanks.
Thank you, Elliot. We're going to move to a technical question for Alvin. Alvin, has your team been able to quantify distinct changes in groundwater recharge signals, and are BDAs as efficient as beavers in recharging?
So yeah, like I said, it's only been 1 year. The stream has been really dry, but we do have groundwater monitoring stations installed, so we are monitoring the groundwater change, and we'll update that as we go further. One more thing about the TEK thing, not all nations are the same. So do your research. Tribes back east don't offer tobacco, so if you're working with it, make sure you understand their protocols and don't paint us all with one brush.
Thank you, Alvin. Elliot, a technical question for you. Could you comment on if you're looking at diseases with these, with the bull trout? And if so, is eDNA a survey methodology there?
No, eDNA won't detect disease. It just detects genetics. And in terms of monitoring for some of the native trout for disease, we're not really monitoring them, but with whirling disease, it results in their spine becomes disjointed. So their spine bends as a result of them getting whirling disease. So they'll start swimming in circles, and that's how you can tell if they've got whirling disease. Because they swim in circles, and then if you catch them, their spine's going to be bent. But other than that, no, we're not really monitoring for whirling disease. And I noticed, I just looked at the chat, there's a lot of questions. Yeah, I would say any adults or youth, if you're interested in joining us in some of our field work or joining us doing some stream habitat restoration or some fish rescues, just contact the Blackfoot Confederacy or Trout Unlimited Canada, and you can volunteer. You can bring your kids, and it's a great learning experience. So I would say, yeah, get involved as much as you can to help. It's a great learning experience, and you can be outside.
Thank you, Elliot. Alvin, two-part question so that you can also respond, as Elliot did, to that question about how people could help or volunteer or support. But first, a technical question regarding relocating of beavers. Have you or your team explored the potential locations within the reserve that you would want to relocate beavers?
So like I said earlier, like it's a complicated issue, right? Like you don't want to be creating problems where there's not, and it would take interviewing multiple land occupants, homeowners, and then ensuring that they want them. Like I said, we're surrounded by rivers that are bounded by both reserve and non-reserve land, so that would take reaching out to non-Indigenous landowners across the river, and right now it's just we don't have that capacity to do that type of work. So yeah, maybe in the future we can get people that'll wrangle beavers and do that type of thing, but as for now, we're against relocating them.
And same question to you, Alvin. There's a kind of a theme throughout of a few questions of people asking for opportunities on how to get involved or help volunteer on some of the work that you've described today.
So yeah, just reach out to our office, call, and they'll get a hold of either myself or Kanzi. And we invite for anything we do: migratory bird surveys, range health surveys, riparian health surveys. We do quite a lot of work with our INI, looking at the interaction they've had. So we've done baseline and current monitoring of different biophysical inventory type of things, and we're engaged throughout the summer. So we always enjoy having people out. We're always here to share knowledge. So yeah, just reach out through email or call our office and they'll get a hold of us.
Okay, thank you so much. There was one comment, if Elliot or Alvin, you can just type into the chat those contacts or who people get a hold of, just a reminder. I think, Elliot, you said Trout Unlimited or the Blackfoot Confederacy. And I think, Alvin, you said to contact, was it the Lands Department?
Yeah.
Okay. Great, thank you so much. We're almost out of time. I am aware that there's a couple hands up, and so I just I wasn't ignoring you. I wasn't able to get to all the questions, but I think there's I don't know if these are accidental hands, but if Jordan, if you wanted to pop on and just ask a quick last question, otherwise I think we're going to have to sign off here pretty quick. Okay. Well, thank you so much, both Elliot and Alvin. This was really, people I think were really excited about this. We had a huge registration and a really big turnout today for our community of practice. Clearly, we ran out of time for all the questions that people had, so I'm sorry about that, but clearly there's a lot of interest. So hopefully we can continue the dialogue, and there'll be other opportunities to engage you within the community of practice in the future. I just want to say thank you so much, and this will be recorded. We have recorded it, and we do post them on the Citizen Science Community of Practice website, so you can watch if you've missed it, or rewatch it if you're interested. And I think without further ado, I'll just say thank you, and we'll let everyone sign off. So thanks again, everybody.
Yeah, thanks for the invitation.
Yeah, and if you guys want to give our contact, you could forward it.
Yeah,
Okay,
yeah, you can give out my email and I can connect you to whatever organization that's doing the work.
Okay, thanks very much. Yeah, there seemed to be quite a bit of interest about how to volunteer and support the project. So that's wonderful. Appreciate that.
Right.
Okay, okay, Elliot.
Okay, Tracy.
Thank you for joining me today. So, Elliot, we wanted to thank you for the wonderful presentation that you gave a few days ago to the Alberta Citizen Science Community of Practice on the Blackfoot Native Trout Project. And if you recall, we just didn't have time to finish some of the questions that were asked. There was a lot of questions from the audience. And so today, Elliot, I'm just going to ask you some of those questions so that we can add this to the video that we are sharing with all the people that attended.
Okay, sounds good.
All right, so we had a number of questions, Elliot, about eDNA. Can you kind of give just a bit more detail about how eDNA works, how long it remains in the environment? How do we actually know that fish are there if you find presence with eDNA?
Okay, well, I'm not an eDNA expert. We just follow the protocol set out in our sampling guide. So it's my understanding that all organisms in the environment shed cells. So we as humans, other animals walking around on the ground out there, and fish in the water. So we all shed cells in the form of hair and skin cells. And with fish in the water, they shed scales. So they leave traces of their eDNA in whatever body of water they're in. So in this case, if we weren't sure of what types of trout were in whatever stream we were researching, we've got a partnership with the University of Victoria, Dr. Karen Helbing's lab. So when we take the water samples, we filter them very carefully and methodically. We usually do 3 liters of water. You can do up to 6 liters of water from one site. And you filter them through a vacuum pump in a little paper filter that's probably a little bigger than a toonie. And so once the water is filtered into the filter, We pop that into a little brown envelope, label it, and keep it in a cooler, or actually we throw it in the freezer. So when we take the water samples out in the field, we put them in a cooler with ice right away, because sunlight deteriorates DNA pretty fast. So we keep the water samples cool. Then when we get to wherever we're going to filter them, and once they're filtered, we freeze the paper filters. We freeze them until we mail them to the lab. And so what Dr. Helbing's lab has done is they've identified the genetic code for 4 trout species that are here in Alberta. So the 2 native trout they can identify with their eDNA are bull trout and West Slope cutthroat trout. And the other 2 trout, which are non-native, they're introduced, at least to the bull and the old man, are brook trout and rainbow trout. So we can tell whether there's one or all of those trout species in whatever stream we're sampling. So and in terms of how long their DNA stays in the water, that's a good question. I'm not totally sure. All I know is that when we get the water samples, we're supposed to filter them within a day. And after that, we can't use the water anymore. So that's kind of my knowledge of eDNA. So I don't know if that answers your question, Tracy.
That was great. Thank you, Elliot. The next questions were around water quality. Do you guys monitor any water quality, or do you have access to water quality data?
We don't. No, we don't monitor the quality. On our data sheets that we're filling out when we do our eDNA water samples, we just observe and document the temperature of the water, the time of day, and if the water is really turbid or murky, or if it's clean and clear. But in terms of actual water quality testing, we're not monitoring the water quality.
Okay, you mentioned temperature. Can you just talk a little bit more about what you're finding with the temperature and how you monitor that?
Yeah, so what we did was we installed, I can't remember right off the top of my head. I think it was right around, I think it was 17 water temperature data loggers we installed in various tributaries in the Old Man and the Bow River watersheds. And so what that entails is there's an electronic device housed in a plastic housing. So you can unscrew this plastic housing. It's white in color. And we attach it to about a 3-foot piece of rebar. And so when we get to the stream, we try to find a place that's the deeper part of the stream that hopefully won't be exposed or dry out over the next year when we return to find the data loggers. We'll pound the rebar into the bottom of the substrate, and then we'll activate there's an electronic device in there. We'll activate it, and we've got an app on our phones that can read each water temperature logger device. They're uniquely numbered, and so we activate it and leave. And so once we activate it, it takes the temperatures of the water in whatever stream it's in every hour.
Oh, wow.
And so next year when we come back to find it, if it hasn't washed away, or yeah, a couple of cases there, our data loggers were close to I guess a campground, an RV campground by the river, and I think either kids or somebody that was, you know, maybe swimming saw them, and we couldn't find them, or they get washed away like with a flood or whatever. Yeah, so we'll find them, activate the device, and then download the data onto our app, and then we can dump that on our laptop, and it gives us a graph of a spreadsheet and a graph of the water temperatures at that site for the past year, or since we installed it, yeah, the prior year. So we can just keep track of the temperatures every hour. And what we found, it's pretty preliminary. Like I'll take an example, like and I use this example in my presentation. You'll see this graph in there if you watch the slideshow. So we looked at the Belly River. So the North Belly River, where the bull trout and the Belly River spawn, we think it's the only tributary they spawn in. So that North Belly River is sourced by a glacier in Glacier National Park. So the glacier melts into a lake, and then it begins the flow of the North Belly River. And then it flows into Waterton Lakes National Park. We've got some timberland, the Blood Tribe does, that's surrounded by Waterton Park on 3 sides. So the lower reach of the North Belly River drains through our, it's called the Blood Timber Limit. And then it enters the main Belly River, and then it flows out into the province of Alberta. So what we did was Waterton installed a data logger, I don't know when, it's been a few years now, way up top on the North Belly River, right by the US border. And then we installed another data logger, probably, I'm gonna say 15 kilometers downstream into the main Belly River. That's just off the Highway 5 bridge that crosses the Belly River when you're heading west on Highway 5 from Cardston to Waterton. It's right below the Bird's Ranch. Anyway, so we put one there, and then we installed one further downstream, probably, I'm gonna guess here, I'll bet you it's 35 kilometers downstream. Anyway, it's right near the boundary of the Blood Reserve, the main Blood Reserve, near Standoff, just north of Standoff, just near the bridge there. So we installed one there. So there was 3 data loggers. So when we retrieved the data the following year, it showed us way up top, the water temperature stayed really cool. I think it remained below 10 degrees, and the lowest it got was like 1 degree or something. And it didn't freeze way up top, which is kind of
Wow.
which is very interesting. And then we graphed the data logger near the Highway 5 bridge. That was higher. I think it was somewhere between 50 and 20 degrees, the highest, maybe around 15. And that froze, the water froze there. And then way down by Standoff, the highest it got was over 25 degrees Celsius last year, which is way too warm for trout. And the lowest it got is it froze. So where these bull trout spawn, they're very similar to salmon. So they'll return when they become big adults. Some remain in their the streams they're born. We call them the natal streams or the nursery streams. They'll remain in those natal streams for the rest of for all of their lives. So they're called resident bull trout. They don't get very big. They probably get, I don't know, 25 centimeters maybe. But then there's the migratory bull trout who migrate out of the natal stream into the bigger, in this case, the main stem belly river. It's more productive, there's more food, and those fish grow pretty big. Yeah, I think the largest one we trapped years ago was right around, just trying to do my metric conversion here. It was around 10 pounds, so I'm thinking,
Wow.
over, what would that be? 10 pounds, kilograms. Yeah, it'd be like 6 kilograms, maybe 5 to 6 kilograms. And, maybe 75, 80 centimeters long. So that's the big migratory fish. So they need the more productive water, and they get bigger. And they usually they'll spawn in September, August, September. Once they're done spawning, the migratory fish will migrate back down into the main river, stay there over the winter, and if they're going to spawn again, if they're healthy enough, they'll start migrating back up to their spawning stream, probably in July, August. And if they're not healthy enough, they'll skip a year of spawning. So they're called alternate year spawners. Yeah, they're called alternate year spawner. So they'll go back to where they were born, and that's where they'll spawn. And so where they spawn is they look for groundwater upwelling into the creek. And so they find that groundwater where there's gravel. The females will dig a nest, a little depression in the gravel, and then the males will be hanging around. They'll spawn, and then they'll cover the nest. They'll swim upstream a little ways, I guess dislodge gravel so it flows and covers the eggs, and that's their spawning bed. And it's right, if it's not near groundwater, those eggs will freeze. And up there it gets really cold in the winter. So that water didn't freeze. So that's how their eggs survive over the winter, where there's groundwater. And unlike salmon, once bull trout die, once bull trout spawn, they migrate back. They don't die.
Oh, wow. Okay. I didn't know that. That's pretty cool. And so the water temperature, when you were talking about the changes in the water temperature as you move from higher elevation down to lower elevation and out into the more, I guess, landscape that's got a lot more land uses. Are you concerned about the migrating species and the water temperature changes? Are you concerned about their ability to migrate back to their nursery streams?
Yeah. I mean, looking at this current year, 2023, it was so dry. This past spring, we didn't get a lot of rain or snow. It was really hot. And so the flows in all of the rivers, I think in southern Alberta for sure, were lower than normal. When they're lower than normal, especially out on the prairie where there's not a lot of cover, they get very warm. And so I'm sure when it gets too warm, I think the threshold for bull trout is 20 point something degrees Celsius. So if they're exposed to that warm of water for, I think it's 7 days, they'll die. But, if it gets that warm, I'm sure they know, and they'll swim upstream where it's colder. But yeah, to me, it just reduces their distribution in whatever river if it gets too warm. And then there's a lot of factors that contribute to, their aquatic habitat or the water. Like here in southern Alberta, it's the irrigation capital of Canada. So there's lots of diversions. The 4 main rivers in southern Alberta are in the Old Man, the Old Man, the Crow's Nest, the Castle. They're all dammed now. The Waterton's got a dam. The Belly is not dammed, but it's got a major weir that diverts water to the St. Mary Reservoir, and the St. Mary is dammed. And so they take a lot of water for irrigation. They send it down east. So that's another factor, is they're taking, in my opinion, they're taking way too much water out of the rivers, and it's definitely affecting the habitat, not only the water, the aquatic habitat, but the riparian habitat, because there's that vegetation depends on the water under the river or around the river. You can't see it, but there's water usually under the whole river valley that you can't see. And when we hiked to do spawning surveys in the North Belly back in the 90s, it was in September, mid-September, and a lot of times it was hot and the lowest flow of the year. So there was some parts of the stream that went dry. And we'd hike further up, and then the river would reappear, and there'd be bull trout in there. So I think once they spawn, if there's no flow, they'll probably, well, they gotta wait. And when the river, when it rains or snows and gets higher, they'll migrate back down. So yeah, there's, obviously concerns. There's concerns with hybridization. Brook trout can hybridize with bull trout. Rainbow trout can hybridize with West Slope cutthroat trout. So there's the non-native species that are impacting them. They compete for food, for their food. There's angling. Some people, they're not supposed to harvest those native trout. Maybe some do. Maybe they don't know what they look like. They take them home and cook them. So over harvesting is a concern. The low flows of the river. And now there's, the irrigation diversions. And then now, of course, there's global warming. So those all contribute to those fish's health.
We did have a question about fishing restrictions. Do daytime fishing restrictions help the fish populations? Does that make a difference?
Good question. I think they probably do. This past summer, it's the first time I've ever heard of the Alberta government implementing a new regulation because it was so hot. So you couldn't fish after 2 o'clock.
Wow, okay.
Because I think what the reasoning I heard was if you catch a fish after 2, it's so warm because, they fight, so they're stressed. They're more prone to not surviving when it's so warm. So that's the first time I've ever heard of fishing restrictions being implemented in the rivers anyway. But yeah, I think they would help.
Okay. A few questions. Can you just remind us of the status of bull trout in Alberta, and then are they also protected in the States?
Yeah, so bull trout status in Alberta is they're threatened, and so are West Slope cutthroat trout.
Okay.
And so they're listed on the Species at Risk Act in Canada, or SARA, as threatened, both of those trout. In the US, I believe bull trout are threatened under the Endangered Species Act in the US. And I believe they're a species of concern in Montana, West Slope cutthroat trout. And it's because these fish, let's take the Belly River as another, as an example again. So they spawn right near the US border in Glacier and Waterton Lakes National Parks. So we call them transboundary. They don't recognize boundaries. They don't recognize that international border. So they're transboundary. So to me, that's pretty significant. Same thing with bull trout in the St. Mary. They're transboundary. We just found some West Slope cutthroat trout in a tributary to the St. Mary River this past year that are also transboundary. So to me, that's they're pretty significant, and I think the government should take appropriate measures to try to protect them as much as possible.
Are you concerned about mountain whitefish populations?
Yeah, for bull trout, mountain whitefish are their main prey.
Okay.
So bull trout are known as pescivores. or they eat other fish. Whereas West Slope cutthroat trout, I'm sure they would eat a smaller fish, but they eat a lot of insects. So they're mostly insectivores. But yeah, bull trout, their main prey is mountain whitefish. So, if the mountain whitefish population starts declining, no doubt it's going to impact bull trout populations.
Okay. Wow, there's a lot of pressure on these species, Elliot.
There is, yeah, but I think what I can say, Tracy, or I know what I can say is they're very resilient. Excuse me. Some of the cutthroat we found in some of the streams out on the prairie, I couldn't believe they were still surviving there, because those streams are so degraded. There's cattle grazing, there's logging, there's random camping, there's off-highway vehicle use.
Wow.
And they're just really damaged in a lot of those streams, but they're hanging in there, so they're really resilient. I guess another thing I should mention before I forget is so bull trout being the top predators in the water. They're an aquatic keystone species, so they're an indicator species. So if bull trout are still there, it indicates that landscape is still in pretty good health.
Okay.
And cutthroat are also indicators. They like cool, cold, clean water. So if they're still there, the water quality is still probably pretty good. If it wasn't, they wouldn't be there. We did some electrofishing in Boundary Creek this year, and that drains into the St. Mary River right by the international border near Carway. So we didn't find any cutthroat in the lower reaches. It was so silty and muddy. There wasn't hardly any gravel on the substrate. And then as we got further higher up near the international boundary west of Carway, Boundary Creek, when the habitat improved, we found cutthroat. So they seek out the better habitat.
Wow. So the solutions are going to be it's a holistic approach to maintaining these species on the landscape. Yeah,
for sure.
Someone just had a question for you, Elliot, about the future. Is there any future work being assessed or other species, in particular in the Milk River watershed?
That's a good question. I'm not very familiar with the Milk River. What I do know is like the headwaters of the Milk start, I believe, in Glacier Park, but it's right close to the eastern slopes of the Rockies in northwest Montana. And then that drains into Canada. There's a secondary highway 501. So when the Milk River enters Canada, it sort of parallels highway 501 heading east towards Del Bonita. So it flows into Canada, and then it crosses the border back into Montana. I think it's not far from Coots. And then it eventually enters the Missouri River drainage and flows into the Gulf of Mexico. So what Montana has done is they've built a diversion canal on the St. Mary River right near Bab and south of the Carway border crossing. And so they divert water from the St. Mary into the Milk River, which when I found this out, I thought, wow, that's probably not good. But anyway, so they got to divert it into a higher elevation over the ridge into the Milk River watershed, and they supplement water into the Milk River. So they're upgrading this diversion. It's really old. It's failing in some places. So in the next couple of years, they're upgrading it so it won't Another thing these irrigation diversions do is they, when they shut the water off, if they don't have mechanisms installed in the diversion canal, fish will get into the canal unless it's screened. So when they shut the water off, any fish in the canal will die because they're trapped. So there's fish rescues happening in Montana and southern Alberta. So they're installing a screen, I believe, on the St. Mary Milk River diversion in Montana. That's going to be a lot more effective, so they won't lose bull trout from the St. Mary into the milk. So I don't know if that answers your question, but and I'm not really familiar with species in the milk. I'm sure when it's colder, I don't think there's bull trout that spawn in the Milk River. There may be cutthroat, but I'm not very familiar with that tributary.
Okay.
I know there are some significant other fish like sculpins, and there's a native catfish that's native to the Milk River. It's called a stone cat. It's a small catfish that's and I don't know the status. I think it's probably endangered, but I could be wrong.
Okay, well, thank you. Those are all our questions, Elliot. I don't know if you have any final words you want to say to everyone about bull trout in particular, or any words of wisdom you'd like to share before we sign off?
Yeah, well, I guess what I'd like to say is, for everybody is, we all need to be concerned about not only these fish, but the water they survive in, which are the rivers, and in some cases lakes, right? But as we've witnessed, it's warming up. It's been crazy the past few years. We've never seen temperatures this high for this long. They're starting earlier and ending later. And, it's really impacting the water. So I think, people can help by being concerned and telling the governments, maybe let's be a little more concerned about some of the fish, because as humans, we depend on water too, obviously. So maybe minimize more diversions on some of the rivers, and, maybe put more money into research so we can identify where these populations are, and maybe develop and implement regulations that would protect them, so our kids and our grandkids, they'll still be here for them. So I guess that's all I need to say right now, Tracy.
Nice. Well, thank you so much, Elliot, for taking the time to continue the dialogue with us and to answer the questions from the community of practice. We really appreciate it, and hopefully we'll see you again soon.
Yeah, I guess one last thing, Tracy. Thanks for the opportunity. I really appreciate it. Just glad to get the word out. But citizen science, there's opportunities out there where anyone that's interested could certainly get involved in some of these research and inventory opportunities that are out there. You can help restore some of the stream banks by planting willow stakes with some of the non-government organizations. You can get out and just be concerned and help if you want. So you can contact, I know, the Alberta government. I know there's Cows and Fish, the Old Man Watershed Council, Trout Unlimited Canada, the Blackfoot Confederacy. There's opportunities if you want to come help. So yeah, just contact whatever agency, and it would be awesome to get more people out.
Great. That's a great word to end on. Thank you for your time today, Elliot.
Thank you, Tracy.